Alright, Logic fans, welcome back to our second video on 6.11. We're going to continue our investigation of the new rule, Identity Substitution. We defined it this way in the previous video, and so now I want to take us through some problems to make sure you're really clear on the different aspects of how identity substitution works. So in each of these cases, A, B, C, D, and E, you have two sentences, and identity substitution is used to generate the third sentence here in the conclusion. And the question is whether or not that application of identity substitution in each of these is permissible or impermissible, not permissible. So let's go ahead and try these now. So pause now, go through these, see if you can't figure out whether identity substitution allows these inferences, and then we'll come back and do them together. Okay, so let's go ahead and do these. Hopefully you've had a chance to figure them out, and this application of IS is absolutely okay. This is permissible. This is legitimate. You can do this, and that's exactly what it's designed to do. So this would be a legitimate use of identity substitution, and if you were justifying it, you would just write IS 1-2 next to it, okay? Now let's go ahead, and also I should mention it wouldn't matter so much if the A is identical with B was written up here in line 1 and the FA was written in line 2. Like if you reverse the order in which these were written, that would not make a difference, okay? All right, now let's take a look at this one. What happens, the only difference between A and B is, the order in which the sort of identity relata are written. Does that matter? No, it does not. B is permissible. This is absolutely allowed. You can do this, and that's what I mean here when I say alternatively gamma is identical with A. So it won't matter which order the identity is written in, okay? And that's the point of A and B here. All right, let's take a look at C. Is C permissible? And yes, it is. C is absolutely permissible. You can do this. It doesn't matter that there's this negation here. Any sentence involving, A, in this case we have it's not the case that FA, and you have B is identical with A or A is identical with B, you can substitute that B in there to get this expression, and that is absolutely permissible. All right, let's keep moving along. What happens in D here is interesting. So we've got A appearing in two places, and we only replace A with B in one of the cases. Is that permissible? Yes, it is. D, this here is a permissible, legitimate, okay use of identity substitution because it says you have to replace at least one token of alpha, possibly all, right? And in this case, they only do all. Now, if you had tried to replace both, that would have been okay as well. But as you can see here, in E, they replace this one instead of this one, right? So instead of replacing the A on the G, they replace the A on the F and leave this one all alone, and that's okay as well. You just have to replace at least one token of alpha, and that's what I mean by that. All right, let's look at a couple of other simple examples. Give these three a try. Pause now. Okay, hopefully you've had a chance to pause and get these, but in this case we have an illustration of replacing multiple tokens of the same individual constant, and also it can be a pseudonym throughout, and that's absolutely permissible as well, right? Possibly all tokens, but at least one is required. So F is permissible. That is a legitimate use of IS. Let's take a look at G. Is G a legitimate use of IS? And the answer is no. This is impermissible. You have to replace at least one token. Not a single token is replaced. Therefore, this is an illegitimate use of IS, okay? So you can't get a repeat of the clause for free that way. All right, let's take a look at H. H is a little bit more complex, but here we have a statement. It's a universally quantified statement. For anything that you pick out of Santa's bag, it satisfies the following description. If it's F, then it's identical with C. It turns out that F is identical with C. Therefore, for all X, if X is F, then X is identical with F. This is permissible. This is a legitimate use of identity substitution, and you are absolutely free to do this kind of thing, even though it's inside of the universally quantified statement. So make sure you're aware of this really nice feature of identity substitution that allows us to do this. And okay, let's finish up the nuances of this new rule by looking at these cases and thinking about them. So pause now and see if you can finish these off. Are these permissible or impermissible uses of identity substitution? Pause now. Okay, hopefully you've had a chance to look at these, but let's go through them together nice and slow. This is just like the previous problem, except there's a leading negation here, and it does not change the validity of the application of IS. This is a legitimate application of IS. This is permissible. Feel free to go ahead and apply IS that way. All right, let's take a look at J. J is interesting. J is permissible. This is allowed. You can absolutely do this. So you've got the identity statement here, and you're going to substitute the F in for the C here. And the fact that there's a non-identity sign there does not matter in this case. Okay, we're going to have to be careful on some of these other cases, but this is a permissible use. All right, let's look at K. Is K permissible or impermissible? This would be impermissible. Do not do it. It is not allowed, right? You have to have an identity statement here, right? The rule here doesn't say anything about having non-identity and what you can do there. So this would not be a correct application of IS. You are simply not allowed to do this. Our syntax does not allow this kind of thing. K is impermissible. Do not do it. Okay, let's take a look at L for all X. Let's go ahead and try this. This would be impermissible, okay? You're not allowed to do this. So first of all, there's a couple of mistakes being made here. First of all, replacing the X with E is impermissible because alpha and gamma, what you replace with, have to be individual constants or pseudonames. That is to say, they cannot be individual variables. So that is prohibited. But also, and that's exactly what's going on here, actually. So there's not multiple problems. That's the problem, okay? The problem is that you're replacing an individual variable, and that's not allowed. You have to be replacing an individual constant or a pseudonym. Okay, so impermissible, do not do it. Criminal, okay? All right, M. Now, let's go ahead and take a look at this case. This would be impermissible, right? And hopefully you've been able to spot why. You do not make the mistake of replacing the X. You replace the individual constant, but you don't do it in terms of one of the identity relatas from the statement in question. So you would have to replace the A with the E. You can't just haul off and go to B, okay? So you're allowed to infer this sentence where this is, right, occurring here. So it would have to be the E. All right. Let's go ahead and take a look at this last case to sort of round out our study of the vagaries of the new rule, identity substitution. You've got a pretty complex sentence here. You get FB or GB or not F. Okay, now here's the thing. So this is not allowed. Do not do this. Okay, now you could get this sentence from this sentence and these two, but you would have to apply identity substitution multiple times. You would first apply it to get the two B's, and then this would remain the D. And then you would replace that sentence, using this one to get the D on the F. Okay, so it would take two applications of identity substitution to get it, but as it stands, doing this in one go is impermissible. Okay, do not do it. That makes other changes to the sentence, and that is prohibited. Okay, so what I'd like to do now is start looking at some actual arguments and highlight some of the nuances of identity substitution. So here's a really interesting case. A is identical with B, that's a premise. B is identical with C. You can, in fact, apply identity substitution to this. So pause now and see if you can't figure out what the result would be. Okay, so hopefully you've had a chance to figure this out, and it gives students a little bit of a problem, right? And the problem it gives it is because you've got two identity statements is all that's going on there. So let's look at this simple case that we're really familiar with, right? Students will really appreciate very quickly if I've got A as F and I've got A is identical with B, I can use identity substitution to replace this A here with a B, and that's fair game, okay? What's going on here is that this is like the FA sentence, okay? This is like, the FA sentence, as it were, right? And this is the sentence that we're going to use to substitute into this one. So we're taking this identity to substitute the C in here to get A is identical with C. And that is absolutely permissible, right? It's just because now you're taking an identity sentence and you're substituting into another identity sentence as opposed to substituting it into a sentence that does not have the identity symbol in it. And that's all that's going on there and why it can be a little bit confusing. So I wanted to point that out. And then students will often also ask, well, gee, Ash, from this, could I also get that C is identical with A, like this, right? Could I do a substitution? And no, there's not a substitution that allows this. But if you did the previous one and got A is identical with C, then you could combine them to get C is identical with A. So to sort of highlight this point, what we'll do is when we write IS 1, 2, we'll let 1 be the sentence that is being substituted into. So this is the one that's being substituted into, and we'll let 2, the one over here, be the identity sentence that's being used to substitute into. And that will always make that clear to you. So this would be correct, right? 1 is the sentence we're substituting into, so we're going to write it down, and we're justifying it with this identity statement. B is identical with C, so the B is getting replaced with the C. So sentence 1 here in this position may or may not be an identity statement, but this one in this position will always be an identity statement. So for example, here the 1 is not an identity statement, but the 2 always will be an identity statement. Okay. Let's try an actual problem here now. And what we have here is we have two premises and a conclusion, and you're supposed to show that the argument is syntactically valid. So produce a syntactic deduction of the conclusion from the premises using our rules. So go ahead and try that now. Pause now. Okay, so in this case, it can take a little bit of trial and error, but after you start seeing these examples, you're going to start getting the idea. And remember, there's plenty of examples in the textbook and the homework problems. So go ahead and if you look at this, right, you've got this non-identity thing, and it's in terms of B. So let's try universally instantiating this to a B. That way we can just see what we're actually working with here, and we see that once we do that, it's like, aha, I've got B is identical with A, and it's not the case that B is identical with A, which sets up a perfect modus tollens. And so these sort of ideas with identity, sort of finessing what you universally instantiate to, in this case to B, based on what you have in other premises and other aspects of the problem you're working on, is a very important problem-solving strategy for identity. And that can be particularly important if you want to try to apply identity substitution. Let's see if we can't look at another example like that and some more advanced cases. We'll just have to spill into another video because we are running low on time. So look for the third video, 6.11c on identity substitution. See you there.